So good morning everyone. We are here again to discuss a new chapter. So we are already in chapter 5, which discusses business and economic forecasting. So forecasting demand or input costs is often quite difficult, but it is one of the pivotal concerns of all managers because the shareholder value of a firm, which is again, di ba, the goal, depends on accurately forecasting these components of the expected future cash flows. So forecasts at the firm level depends not only on the prices and advertising and rival response tactics, but also on the growth rate of the macroeconomy, the level of interest rates, and the rate of unemployment, and so on and so forth. So, in this chapter, we will discuss the strengths and weaknesses of several classes of forecasting techniques, which include trend analysis, smoothing techniques, barometric indicators, survey and opinion polling, and time series econometric methods. So, an overview of the things that we'll be discussing. We have the significance of forecasting, selecting a forecasting technique, alternative forecasting techniques, deterministic trend analysis, smoothing techniques, barometric techniques, survey and opinion polling techniques, econometric models, forecasting with input-output tables, and the stochastic time series analysis. So let's start with the significance of forecasting. So accurately forecasting future business prospects is one of the most important functions of management. So sales examples of which are sales forecasts are necessary for operations managers to plan the proper future levels of production. Another use is that financial managers require estimates of not only future sales revenue but also disbursements and capital expenditures. Another, forecast of credit conditions must also be made so that the cash needs of the firm may be met at the lowest possible cost. So these are just some of the functions or significance of forecasting in your management. However, forecasting can also be applied or can be used by public administrators and managers of not-for-profit institutions. So forecasting can be used in different ways. So if we are to do forecasting, then we need to know what forecasting technique to use. So we have here, how do we select a forecasting technique? So there is a hierarchy of forecasts. So the highest level of economic aggregation that is normally forecasted is that of the national level or national economy. So the usual measure of overall economic activity is, of course, the GDP, though a firm may be interested also in some specific components of GDP. So, for example, a machine tool firm may be concerned about plant and equipment expenditure requirements, while retail establishments may also be concerned about future levels and changes in disposable personal income rather than the overall GDP estimate. So that is the first level, which is those that involve the national economy. The next level in the hierarchy of economic forecast is your industry sales forecast, which is, and then followed by your individual firm's sales forecast. So a simple single firm forecast might take the industry sales estimate and relate this to the expected market share of the individual firm. So that is from industry, which can be applied to the individual firm. So future market share might be estimated on the basis of historical market shares as well as on changes that are anticipated in marketing strategies, new products, model changes, and relative prices. So within the firm, so this is inside the firm. No, within the firm, there is another hierarchy of forecasts that exists. So managers often estimate company-wide or regional dollar sales and unit sales by product line for use of operations. So these forecasts may be used in this forecast may be used by operations managers, they can be used by marketing managers, or can be used by sales managers. So long-term forecasts for the economy, industry, and firm are also used in planning long-term capital expenditures and for charting the firm's general direction. So that is the hierarchy when it comes to the individual or within the firm itself. Now, what are the criteria that you need to take into account when you are to select a forecasting technique? So, as I mentioned, forecasting techniques, diba, there are a lot of different techniques as mentioned in the overview ganiha. There are some techniques that are simple and expensive to develop and use and best suited for short-term projections. However, there are also techniques that are extremely complex, that require significant amount of time to develop and may be quite expensive. So the techniques used in any specific instance depends on a number of factors. First is the cost of developing the forecasting model. You need to take into consideration also that the complexity of the relationships that are being forecasted. So of course, if they are too complex, you cannot expect that a simple forecasting technique would be used to analyze complex relationships, diba? So another criteria is the time period of the forecast, may it be short-term or long-term, because there are some techniques that can only be applicable for short-term decisions, while others can be applicable for long-term. Another criteria is the lead time needed to make decisions based on the forecast. So there are instances wherein you need an immediate forecast already, while there are some that you have a lot of lead time, or you don't need to get the results of the forecast right away. So there can be more time to gather data and so on and so forth. And lastly is the accuracy required of the forecasting model. So these are the criteria used to select a forecasting technique. Next is evaluating the accuracy of forecasting models. So in determining the accuracy or reliability of a forecasting model, one is concerned with the magnitude of differences between the observed or the actual and the forecasted values. So various measures of model accuracy are of course available. So for example, if you can remember in our discussion in chapter 4 about regression analysis, when we were talking about the coefficient of determination or R squared, it it was used as a measure of the goodness of fit of the predicted values from the model to the patterns in the actual data. So in addition, the mean prediction error, if you can remember, or the root mean square error, or in this case, the RMSE, root mean square error, is often used to evaluate the accuracy of forecasting model, where your N here is the number of observations. So the smaller the value of your RMSE, the greater the accuracy. So your Y here is your actual value, and then your Y with a circumflex, with a sign like that is a circumflex. So that is your forecasted value. So again, the smaller the value of your RMSE, the greater the accuracy of your forecast. So that is how you evaluate the accuracy of your forecasting models. Now let's move on to the different forecasting techniques. So these were already mentioned a while ago in the overview You have the deterministic trend analysis, you have smoothing techniques, barometric indicators, survey and opinion polling techniques, macroeconomic models, stochastic time series analysis, and forecasting with input-output tables. So let's start. We'll be discussing this one by one, and then let's start first with the deterministic trend analysis. So data collected for use in forecasting the value of a particular variable may be classified into two major categories, which is your time series and your cross-sectional data, which I believe you've already encountered these terms in your BA 319, diba? So your time series and cross-sectional data. When you say time series, these are defined as a sequence of values of an economic variable at different points in time, while your cross-sectional data is an array of value of an economic variable observed at the same time, like the data collected in a census across many individuals in the population. So no matter what type of forecasting model is being used, one must decide whether it is a time series or it is a cross-sectional data, because again, their treatment would be different. You have a different application if you would use time series, and then it would also be different if you're dealing with a cross-sectional data. So let's start with your time series. So what are the components of a time series? So in the analysis of time series data, time in years, months, or weeks is presented on the horizontal axis, and the values on the dependent variable are on the vertical axis. So there are the time series is composed of 4 components. So you have the secular trends, cyclical variation, seasonal effects, and random fluctuations. So there will be in the next slide, there are graphs that you can, or that I'll show you to really differentiate these 4 trends. So when we say secular trends, these are long run trends that cause changes in an economic data series. So for example, in empirical demand analysis, such factors as increasing population size or evolving consumer tastes may result in trend increase or decrease of a demand series over time. So if you can remember, these relate to your determinants of demand, diba? So again, these involve long-term changes. So example, increasing population size, of course, it affects long-term, diba? Then same with your let's say if there's an increase in consumer income, diba? So it has a long-term impact. So thus it follows a secular trend. Next is cyclical variations. So these refer to major expansions and contractions in an economic series that are usually greater than a year in duration. So for example, the housing industry appears to experience regular expansions following contractions in demand. So when cyclical variations are present, regression estimates use the raw data will be distorted due to the presence of positive autocorrelation. Thus, care must be taken to specify an appropriate lag structure to remove the autocorrelation. So another is the seasonal effects. So seasonal variations during a year excuse me, tend to be more or less consistent from year to year. So I believe we are very familiar with the seasonal effects. Like for example, during Christmas season, so starting from September to December, those products or services that are in relation that relate to the Christmas season, like the sale of Christmas trees or Christmas decorations, diba? So their sales during the Christmas season increases. So that is an example of a seasonal effect. So after the Christmas season, of course, it would decline again, and then it would go and increase again during the Christmas season. So the same trend happens every year. So that is an example of a seasonal effect. The next or lastly is the random fluctuations, wherein an economic series may be influenced by random factors that are unpredictable. So keyword here is unpredictable. That is why it is random. So such situations may be due to hurricanes, floods, extraordinary government actions like wage price difference, wage price freeze, or a declaration of war. So again, fortuitous events can also, or fortuitous events may lead to these random fluctuations. So let's move on to the graph so you will really see the difference. So in here, when you say secular trend, but it is just a constant increase or a decrease. It would depend. While your cyclical variations, as you can see here, its effect is over a long period of time. So it deals with more than 1 year in duration. So if it in 1995 to 1997 it was increasing, and then it decreased again down to 1999, and then it increased again down to 2000. So there is a constant increase from 2000 to 2002, and so on and so forth. So it hovers over a year in duration. So that is your cyclical and your secular. While your seasonal effects, diba, you have here your year 1 and your year 2. So as you can see here, diba, there is an increase from your there is your peak seasons are in August, July, August, September. So that is your peak season. And then for the next year, still there is an increase in your July, August, and September. So diba, this is what you can consider as your seasonal effects. While of course your random fluctuations, it would depend any month. It can be an increase, it can be a decrease. You can have sudden decreases, or like just like this one from October to November, then just constant on the next month, and then you can have an increase again. So again, you cannot exactly predict, okay, because they are due to unpredictable events, just like fortuitous events. So those are your components of a time series data. So the simplest time series model states that the forecast value of the variable for the next period will be the same as for the present value. So you have here your y circumflex, you have your t, your current year, plus 1 is equals to your actual value at the current year. So let's have this example. So if you can see in here in your table 5.1, to forecast monthly sales, the model uses actual beer sales for March of 2007 of 2,738 barrels. So these are thousands of barrels, whereas to forecast the value for your April. Now, okay. Where is it? So, as you can notice, the changes in the values of your beer sales each month occur slowly, and with that, the forecast is being made for a relatively short period in the future. So that is why time series model may be quite useful. However, because of because this equation requires knowledge of the months, the current month's sale. Since again, as I mentioned, this is the basis for your next month, or your next period. The forecaster may be faced with the task of speeding up the collection of actual data. Diba? So, even though, for instance, by March 16, you're already trying to forecast your sales for April, you cannot simply do that right away because you are still on March 16. You haven't, wala pang human ang month, di ba? So, that is why, if you are to do this, you need to speed up the collection of your data. Then another problem with this model is that it makes no provision for incorporating special promotions by the firm or its competitors, which could then cause large sales deviations. So if you have sudden discounts or sales, of course, it would increase your sales for the next period if you plan to have a sale on the next period, diba? So again, it doesn't take into consideration that. Now, in table 5.1, there it indicates a slight upward trend in sales. As you can see, slight upward trend in sales, wherein beer sales in most months are higher than in the same month of the previous years. If you compare 2012 and 2013, diba, there is a slight increase between both years. So, second is, if you can see that sales are somewhat seasonal, meaning beer sales are high during the summer months and low during the winter months. So, as you can see here, May, June, July, and August, diba? These are your summer months. So there is an increase in your beer sales in comparison to your winter months, which is November, December, January, February. So it also follows a seasonal effect. So the tendency for recent increases to trigger further increases in beer sales may be incorporated by adjusting the equation in your 5.2. So, kanina, the equation was only up to here. Diba? Meron ni siyang ganiha. However, you incorporate, diba, the possible changes. So, you added this one. The difference between your current, the current period's actual sales minus the previous month or previous period. So if we follow this table, if we refer to this table, this is your current, this is your YT, and your YT minus 1 is your February. With that, you can arrive at your forecasted sales for April at 2,783 barrels. So that is how you do the time series model. So next we have the secular trends, wherein again they refer to long-run changes in an economic time series and can follow different types of trends. So it can either be a linear trend, a non-linear trend, which follows a constant rate of growth pattern, and a non-linear trend of a declining rate of growth. So as you can see here, this is your linear trend. You have a constant rate of growth trend, which is denoted by this formula, and then your declining rate of growth trend, which is denoted by this formula. So that is your secular trends. So let's start first with your linear trend. So a linear trend may be estimated by using your least squares regression analysis to provide an equation of a straight line of best fit. So if you can remember, we've already talked about least squares in your previous chapter. So the equation of a linear time trend is given in this general format. So you have your y circumflex is equal to your alpha plus beta, and your variable this time is your t. So if you can remember, this formula is just the same as your linear formula in the previous chapter, di ba? Y is equals to mx plus b. So this is just basically the same. Where in your y circumflex is the forecast or predicted value for the period t, and then your t is of course your t is a period, and then your a is a your alpha is the y-intercept or constant term. Your t here is your unit of time, and your beta here is an estimate of the trend factor. So linear trend forecasting is easy and inexpensive. This is supposed to be inexpensive, but too simple and inflexible to be used in many forecasting circumstances. So it cannot be applicable to any kind. It cannot be applicable to all kinds, diba? Since it is simple. So in this case, we can make use of the constant rate of growth time trends. So the formula for the constant rate of growth forecast model is this one. So where your y circumflex is your forecasted value for period t, which is equal to your y and then subscript 0. So it is the initial value of the time series, since your t is equal to 0. And G here is the constant growth rate per period, where T is of course your unit of time. So the predicted value of the time series in the period T is equal to the initial value of the series in your initial value, or your y0, compounded at the growth rate of G for T periods. This is it. This formula is just like the same if you are computing for the present value factor, diba? Mura siya inani na formula if you can remember. So mura siya inana. Now, because equation 5.5 is a nonlinear relationship, the parameters cannot be estimated directly with the ordinary least squares method, but taking logarithms of both sides of the equation gives us this formula. So gilog rani niya kaning formula. So mahimo na siyang ingon ani. So wherein your y circumflex niya t na may apostrophe is equals to your log is equal to this one, and then your alpha is equal to this one, and your beta is equal to this one, and then multiplied by your t. So this equation is already a linear relationship whose parameters can be estimated using standard linear regression techniques. So if maka-remember mo, this is slightly similar with this one. So, the difference lang is your t here is nakalog na siya, or log na siya, hindi mo na siya gilog. So next, the third one under secular trends is your declining rate of growth trends. So if you can remember in the figure 5.3, it's particularly useful for representing sales penetration curves in marketing applications. So using linear regression techniques, one can specify a semi-log estimating equation with this. So have your log y circumflex t is equal to your beta 1 minus beta 2 multiplied by 1 over t, and recover the beta 1 and 2 parameters of this nonlinear diffusion process as a new product spreads across a target population. So your beta 1 and beta 2 measure how quickly a new product or new technology or brand extension penetrates and then slowly or ever more slowly saturates a market. So that is your secular trends. Now let's move on to seasonal variations. So When your seasonal So when the seasonal variations were introduced into a forecasting model, its short-run predictive power may be improved significantly. Now, seasonal variations may be estimated in a number of ways, either ratio trend method or through dummy variables. So when we say ratio to trend method, this method assumes that the trend value is multiplied by the seasonal effect. So that is ratio to trend. When we say dummy variables, a dummy variable is a variable that normally takes on one of two values. So that's either 0 or 1 and is used to capture the impact of certain qualitative factors in an econometric relationship. And this method also assumes the seasonal effects are added to the trend value. So if a time series consists of quarterly data, then the following model could be used to adjust for seasonal effects. So as you can see here, you already have this refers to your quarter 1, this refers to your quarter 2, quarter 3, and quarter 4. So so as you can see here, there you already have an additional variable which is your D. So your D1T here is equal to 1 for first quarter observations and 0 for otherwise. Your D2 here refers to your second quarter observations. So it can be 1 or 0. Again, dummy variables, ready siya ang imuhang D dire. So it can be 1 or 0. 1 if it refers to the observation and 0 if none. So the A and B, or the alpha and beta, are still parameters to be estimated using the least squares technique. So in this model, as I mentioned, your D1, D2T, and D3T are the dummy variables. So this can be used for observations in the fourth quarter of each year, which would be equal to 0. So in the estimated model, the value of your B2D1T represents the impact of the first quarter observation on the values of the forecast. YT relative to the forecast from the omitted class, which is the fourth quarter, when the D2T and D3T take values of 0. So the introduction of these trend and seasonality factors into a forecasting model should significantly improve the model's ability to predict short-run turning points in the data series, provided the historical causal factors have not changed significantly. So the models of time series trend forecasting discussed in the previous slides may have substantial value in many areas of business. However, such models do not seek to relate changes in a data series to the causes underlying observed values in the series. Thus, other techniques, forecasting techniques, can be used on those kinds of situations. So let's move on to the next technique, which is the smoothing technique. So smoothing technique is another type of forecasting model. Excuse me. Again, it's another type of forecasting model which assumes that a repetitive underlying pattern can be found in the historical values of a variable that is being forecasted. So by taking advantage of your past observations, smoothing techniques attempt to eliminate the distortions arising from random variations in the series. As such, your smoothing techniques work best when a data series tends to change slowly from one period to the next with few turning points. So, smoothing techniques are cheap to develop and are inexpensive to operate. So, smoothing techniques makes use of moving averages. So, If a data series possesses a large random factor, a trend analysis forecast, as those previously discussed, will tend to generate forecasts having large errors from period to period. So in an effort to minimize the effects of this randomness, a series of recent observations can be averaged to arrive at a forecast. So that is then your moving average na method. So a number of observed values are chosen, their average is computed, and this average will serve as a forecast for the next period. So I think moving averages is nothing new. I believe you've already experienced or you've already encountered this method in your accounting, either cost or financial accounting. So it is defined in this general formula. So where your y circumflex t plus 1 is equal to the forecast value of y for the period in the future, and then these values are on top are your observed values, and then your capital N is your number of observations in the moving average. So the greater the number of observations, or your N here, used in the moving average, the greater the smoothing effect, because each new observation receives less weight because they are 1 over n. Diba? The value of this observed value and this observed value is just 1 over n. So that is why as n increases, the smoothing effect also increases. Hence, the greater the randomness of the in the data series and the slower the turning point events in the data, the more preferable it is to use the relatively large number of past observations in developing the forecast. So the most appropriate moving average period is a choice of n that minimizes the root mean square error, or your RMSE. Next, let's move on to your first order exponential smoothing. So one criticism of moving averages as smoothing techniques is that they normally give equal weight to all observations. If you can remember in the previous slide here, as I mentioned kanina, 1 over n ilang value. So, so if equal weight to all observations. So even though the most recent observation probably contains more useful information. So with that, the exponential smoothing is designed to overcome this objection. If you consider the following alternative forecasting model, so this is the alternative. This model weights the most recent observation by W. So naanay weight ang kada value nimo. Kada observed value, there is already a weight, which is some value between 0 and 1. And the past forecast by 1 minus W. So this is the weight of your previous forecast. So a large W indicates that a heavy weight is being placed on the most recent observation, because of course, maman ang imong mamultiply diri sa imong current na observation. So using the equation 5.15, or this one, a forecast for y circumflex t may also be written as follows. So can be written into this. Ang gibuhat niya is your yt here. No, not that one. Your this one, your yt here. No, this one is being isolated. So derive rin siya, guys. Imo rin siyang ipang-derive. So apply algebra derivatives. Then, by substituting the 5.16 into the 5.15 equation, so this is the 5.15 equation, diba? plus your 1 minus W YT. So, ang katong imong YT dire, ang kani siya nga formula is imo siyang i-substitute are dire. And then, once you substitute it there, di ba, imo pa man siyang ipang-distribute. So, that is why, as you can see here, na kay 1 minus W squared, di ba, kay distribute na ito ninyo, squared na siya, and so on. So, again, just apply algebra. You can do the derivation at your own time. So, by continuing this process of substitution for past forecast, we can obtain the general equation. So, this is the general equation. That is ... because it would depend on how many observations there is. So, equation 5.18 shows that the general formula for an exponentially weighted moving average is a weighted average of all past observations with the weights defined by the geometric progression of this one. So, this is your geometric progression. So, for a sample of a W of 2/3, it would produce the following series of weights. So, kani siya nga weights ang imuhang gamiton dinhi. Diba? 1, 3, and so on. So, this is what you will use. So, with a high initial value of W, heavy weight is placed on the most recent observation and rapidly declining weights are placed on older values. So, as you can see here, your W again has the greatest weight, and then as it decreases, magkagamay po ang iyang weight. Or as the number of observations increase, their weight of the additional observation will also decrease. Will decrease here. So, meaning the oldest observation that you accounted for would also have the least weight. So, samtang magkadugay siya. So, for example, this is your 2021, this is your 2020, 2019, 18, 17, 16. So, diba, samtang magkadugay siyang observation is magagamay ang iyang weight. So, muna na yung ano. So, another way of writing equation 5.15 is this one. So, this indicates that the new forecast is equal to the old forecast plus your weight times the error in the most recent forecast. So, a W that is close to 1 indicates a quick adjustment process for any error in the preceding forecast. Similarly, a W closer to 0 suggests a slow error correction process. So, it should be apparent that from equation 5.15 to 5.20, that exponential forecasting techniques can be very easy to use. It may be intimidating since the formula is kind of long. Mura siya long, guys. But if you basically analyze the formula, is mura na siya taas. Kaya tungod nag-derive ka. But basically, it is just very easy to use. What you just need is the last period's forecast, last period's observation, plus a value for the weighing factor. Weighing factor W. So, the optimal weighing factor is normally determined by making successive forecasts using past data with various values of W and choosing the W that minimizes the RMSE given in equation 5.1. So, basically, you just need 3. Again, last period's forecast. So, you have the YT, last period's last period's forecast is a Y circumflex T. The last period's observation is your YT. And then you have the weight. So, muna siya ang imuhang kailangan basically. So, next, let's move on to barometric techniques. So, the time series forecasting model, which was discussed earlier, assumed that future patterns in an economic time series may be predicted by projecting a repeat of past patterns. But very few economic time series exhibit consistent enough cyclical variations to make this method reliable to see. So for example, as you can see in table 5.6, it conveys why the prediction of a business cycle's turning point proves to be so difficult. So although the duration of post-war US business cycles averages 70 months, business cycles, their average is said to be at 70 months. From peak to peak, 3 cycles have lasted 100 months or more. So, ano siya, di ba? 3 cycles per me ang last 100 months or more. And then, there are others that can be as short as 32 months or 18 months. Yung ano siya, 32 months or 18 months. So, economists, however, have long recognized that if it were possible to isolate these sets of time series that exhibited a close correlation, and if one or more of these time series normally led in a constant manner the time series in which the forecaster had interest, then these leading series could be used as a predictor or barometer. So that is why we have what you call the leading, lagging, and coincident indicators. So these economic indicators, again, as I mentioned, may be classified as leading, coincident, or lagging, and depending on their timing relative to a business cycle's peaks and troughs. So, leading and lagging indicators predict the direction of future change in economic activity, not the magnitude of changes. So, masikasabot siya diri. So, you have your leading, coincident, and the lagging indicator. So as you can see here, this is set to be the business cycle's peak date. This is the business cycle's throw date. So when you say leading indicator, when you say leading indicator, di ba? It hasn't reached yet the business cycle's supposed to be peak date. Ni peak na siya. So it is already leading. So that is why it is called leading. Peak siya before the said peak or before the usual business cycle's peak date. Now, same with the throw date. So, yung throw date is before pod sa projected na or the usual business cycle's throw date. So, ano siya, di-decline na siya by that certain period and nagsaka na gani siya balik in comparison to what was expected to be its throw date. Now, coincident indicator is, ay siya, nag-follow siya sa ihang normal level. So, it peak at the said peak date and then i-decrease po siya at the said decrease date. Now, lagging, kani siya is naglag siya. Mo ni siya ang designated nga period nga mo peak ang kanang business. However, ang peak is na happen na after the said business cycle na date, peak date. So, di ba, after na siya. Same with the throat date. Iyon nga, kani siya more declining. Pero, ang real decline is happen pag siya the day past the said business cycle throat date. So, that is leading, coincident, and lagging indicator. So, again, these indicators doesn't show the magnitude of the change. So, they just refer to the direction. So, kani leading, nag-una, coincident is the same, where lagging is nawahi siya. So, ana. Next technique is your survey and opinion polling techniques. So, this can be used if you are dealing or if you are trying to make short-term or short period forecast. So, the greatest value of survey and opinion polling techniques is that they may help to uncover if consumer tastes are changing or if business executives begin to lose confidence in the economy. So, survey techniques may be able to uncover these trends before their impact is felt. So, you have forecasting macroeconomic activities, which include plant and equipment expenditure plans. You have plans for inventory changes and sale expectations. You also have consumer expenditure plans. So these are just some of the known surveys available for private and governmental sources. So let's move on to sales forecasting. So opinion polling, and survey techniques are used on a micro level within the firm for forecasting sales. So some of the variations used include the following. So you have sales force polling, wherein some firms survey their own salespeople in the field about their expectations for future sales by geographical area and product line. So the idea is that the employees who are closest to your customers may have significant insights to the state of the future market. Another is your surveys of consumer intentions. So some firms, especially those engaged in durable goods industry, conduct their own surveys of specific consumer purchases. So for example, an auto dealer who pursues a customer for life relationship with his or her target market. So such a dealer or a future furniture company may conduct a mail survey to estimate target household intentions of purchasing replacement autos or furnitures. So that is your survey and opinion polling techniques. Another forecasting technique is your econometric models. So econometric is a combination of theory, statistical analysis, and mathematical model building. Models can range from simple to extremely complex models. So, econometric techniques for demand estimations were already discussed in the previous chapter. Now, the advantages of econometric forecasting techniques. First, these possess significant advantages over other types of models. Next, the most significant advantage is that they identify independent variables such as price or advertising expenditures in a demand model, if you can remember chapter 4's sample problem, and that the manager may be able to manipulate. And then another advantage of the econometric model is that they predict not only the direction of change in an economic series but also the magnitude of that change. So this represents a substantial improvement over the trend projection models, which failed to identify turning points, and the barometric model, which do not forecast the magnitude of expected changes. So under econometric, you can have single equation or multi-equation models. So single equation models is of course the simplest form of an econometric model, and it was developed for explaining the, as you can remember, explaining the demand for the Sherwin-Williams house paint in your chapter 4 discussion. Diba? We talk about the price, the income, and the promotional expenditures. So, siya. Once the parameter of the demand equation are estimated, the model can be used to make forecast and demand for a particular product in a given region. Another one is the multi-equation models. So, although in many cases, single equation models may accurately specify the relationship that is being examined, frequently the interrelationships may be so complex that a system of several equations becomes necessary. So, this can be illustrated by examining a simple model of the national economy. So, this is just an example wherein you have C here as a consumption expenditure, the I as investments, your T refers to your taxes, GDP of course, gross domestic product, and your Y is the government expenditures. So as you can see here, in your equation, what do you call that? Equation 5.21, 22, and 23, these are behavioral or structural equations, while 5.24 and 25 are identities or definitional equations. So, once parameters of a system of equations has been estimated, forecasts may be generated by substituting known or estimated values for the independent variables into the system and solving for a forecast. So, if you can see here, in your T, if you already have the value of your GDP, remember siya connect lani siya ba ang imuhang relationships. That's why there's interrelationship. So before pa niyo makuha ang T, diba, you need to have the GDP. However, in order to get the GDP, you need to get your consumption expenditure, your investment, and your national income first. So however, diba, in your no, not national income, but your government expenditures. So muna siya. So in case if you would like to get your national income, you need to have your GDP and T. So substitute ra mo ani. Next, let's move on to our second to the last forecasting model or forecasting technique, which is stochastic time series analysis. So this forecasting approach capitalize on the interdependencies in business data. So deterministic trend analysis, as discussed earlier, was concerned with extrapolating deterministic past trends in the past. So just like the seasonal effects and your population growth time trends. In contrast, your stochastic time series analysis attempts to remove deterministic time trends and instead model, estimate, and hopefully replicate the stochastic process, generating any remaining patterns in the data across successive time periods. So if you consider a simple autoregressive first order process with a positive drift of alpha. So this equation wherein your beta is equal to 1 by hypothesis, and where your epsilon t is a pure white noise disturbance drawn independently each period from a zero mean constant variance normal probability distribution. Now, ano siya masabot? And the IID here refers to your independent, identically distributed, and disturbance. So next is random walk variables. So random walk variables pose several problems if one tries to make a forecast based on OLS or ordinary least squares regression analysis. So for one thing, two random walk variables with positive or negative drift will almost certainly exhibit spurious correlation. So because each series is trending upward if it is positive and downward if negative, and not reverting to its mean, an ordinary least squares regression estimation or an OLS estimation on two variables generated by the process in the equation 5.26 will indicate a significant positive relationship between the variables when no causal link between the two exists. So, of course, not all business time series exhibit these random walk properties. So, for example, a firm's profitability and earnings do mean revert in response to competitive entry and exit whenever they move substantially above or below the risk-adjusted mean for the industry, and therefore profits and earnings are not a random walk. Hence, it is crucial to know whether the data one is working with are or are not generated by a random walk process. Now, the second problem posed by random walks is that the level of your YT after a number of periods T is denoted by this formula. So the cumulative sum of the drift parameter plus all the white noise errors up to period T. Another way of describing this phenomenon is to say that all innovations to random walk variables result in permanent effects. So the shocks just continue to accumulate and don't wash out as the time series lengthens. Therefore, trends in business data have two meanings. First, Some trends are deterministic, like upward and downward sales trends for, let's say, bathing suits in spring and summer versus the fall and winter by seasons. Now, another trend, however, are stochastic, meaning they are permanent or they have permanent effects of innovation in a random walk process. Lastly is your forecasting with input-output tables. So, another forecast approach that capitalizes on the cross-sectional interdependence between various intermediate product and final product industries is, of course, your input-output analysis. So, this analysis enables the forecaster to trace the effects of an increase in demand for one product to another industry. So, for example, an increase in the demand for autos will lead to an increase in the demand for steel, glass, plastics, tires, and upholsteries because, diba, in order to create the auto, which is your output, you need the following inputs. So if there is an increase in your output, there is also an increase in the, let's say, demand for your inputs as well. Aside from that, given that there is a increase in demand for your inputs, secondary impacts will occur as the increased in the demand for upholstery fabrics. So for example, these inputs, which in turn are also outputs, diba? These are also products essential. Their specific inputs, let's say ang upholstery fabric, diba? Their specific input is the fibers used to make the fabric. So the fibers of the fabric will also have an increase in demand because there is an increase in demand in upholstery fabric and so on and so forth. So there is like a domino effect siya ba. So muna siya ang sa imuhang input-output analysis. So input-output analysis permits the forecaster to trace throughout all these inter-industry effects that occur as a result of the initial increase in the demand for the product that you are dealing with, or your primary product. So in this case, for the automobiles. So that is your forecasting with input and output tables. So that ends the discussion for chapter 5. So just a recap. Again, when we talk about forecasting, it deals with a prediction concerning future value of some economic time series. Now, there are different forecasting techniques, so it can be deterministic or not. When we talk about deterministic, so they deal with time series and cross-sectional. And if they are not, we have stochastic time series models. So, that is all. If you have questions, you can just post it to the group chat.